Hello everyone, welcome back to another Geostats lecture video. And in this lecture video I want to walk through the other type of spatial lag model, which is the spatial lag Y model. And so this is going to look very similar to the spatial lag X, just like when we talked about the equations, right? They're conceptually very similar, but what they're tackling are two different cases. With the spatial lag X model, right, we were tackling the idea that the independent variables of my neighbors were affecting my dependent variable, right? That's what the lag X was doing. With the lag Y, right, we're tackling a slightly different proposition. With the lag Y, again, we're saying that not only do my X's impact my Y, right? Not only do my independent variables affect my dependent variable, but also my neighbor's dependent variables affect my dependent variable. Right? So to put this in sort of concrete terms relative to the model that we're working with here, right? Whereas the spatial lag model was saying, hey, not only does my smoking rate affect the cancer rate of my polygon, but my neighbor's smoking rate affects my cancer rate. Right? That's what the lag X was saying. The lag Y model, on the other hand, is saying, hey, not only does my smoking rate affect my cancer rate, but my neighbor's cancer rates, right? Again, that dependent variable, my neighbor's cancer rates also affect my cancer rate. So hopefully that distinction makes sense. And the reason I bring that up is because it's a critical distinction, not just in terms of what function we call and in terms of what sort of fundamental question we're addressing, but it also affects how we interpret the model result. Okay? So to do the spatial lag Y model, we're going to be using a function from spatial regression called lag SAR SLM. Right? Simultaneous autoregressive model, or the spatial lag Y model. So if we scroll through all of this stuff, get down to usage, right? You'll see that we're going to do the lag SAR SLM, that this takes in, just like our spatial lag X model, it takes in the formula, it takes in the list of data, and then it takes in this list W. Those are going to be the things that you're going to need to be concerned with. So let's go ahead and let's build out our spatially lagged Y model. So that's SLY for spatially lagged Y. We're again going to be using the spatial reg package. And in the spatial reg package, we're going to be, again, using the lag SAR LM. And it's basically going to take the exact same stuff. It's going to take a formula. It's going to take data. And it's going to take a list W, which is the spatial weights matrix. So we're going to do the exact same thing we did for the spatial lagged X, right? It's cancer rate regressed against smoking. The data is going to be the pen underscore UTM at data. And then this list W is going to be the pen underscore spatial weights matrix. Okay. So again, formula, data, spatial weights matrix. And if we run that, we don't get any errors, which again, always a good thing. So now if we do summary of SLY, you will see what I was talking about when I said that this has a slightly different interpretation. So whereas the spatial lag X model, right, had the intercept smoking, and then it had a smoking.lag, which was the value of our neighbor, right? Now we have instead this row here. And this row, if you remember back to our discussion on the equation of a spatial lag Y model, right? This rho is that coefficient for the spatial dependency of our neighbor, for the dependent variable, right? So this rho is that slope for our spatially lagged y. Now, here's the problem with interpretation, right? We can't just take this rho as our indirect effect, and we can't take the smoking as our direct effect, because there's this sort of feedback loop happening here. Because you have to think about what we're saying is that, oh, my x's are affecting my results, but my neighbor's y are affecting my results as well, which would feed back into, well, my neighbor's x's are affecting my neighbor's y. So there's this sort of weird feedback happening that requires a little bit of additional interpretation. And so in order to do that, we have to go back through and do that impact again. But because we're doing the spatial lag y, it's a little more complicated. So I actually want to bring back up the help documentation for the spatial for the impacts. So spatial reg : impacts. Okay. So if we look down here at the arguments, we skipped over this right here, which is the R. And so what the R does is it basically calculates these impacts using a Monte Carlo simulation approach. And what that's going to do is that's going to take these estimates and it's going to convert them into impacts in the same way that we've read them with spatial lag and ordinary regression. So we're going to call that really quickly, and I'm going to show you what that looks like. So we'll call spatial PATIAL reg : impacts. And again, impacts in this case is going to take the object, which is our spatial lag y model. It's also going to take in our list W, which is going to be the pen SW. And then finally, it's going to take in this R parameter. And this R parameter is the number of iterations. So you want to set that relatively high. We're going to go with 1,000 here, and we're going to run that. It's going to take just a second. Okay. So we have a value of 17.46, 1.47, and then 18.94. And what I want to draw to your attention here is that the direct and indirect here are not the same. Right? Again, they are not the same as the beta coefficient for smoking and the rho. Right? The actual effects are different from the coefficients in this case. Okay, and I want to make that incredibly clear. The effects, which are the sort of relationship that we're thinking about in the case of a spatial lag y model, are different from the coefficients, are different from the beta and the rho. Okay? So what is this actually saying? It's saying our direct effect, right? So the effect of us raising our smoking rate is 17.46. The indirect effect, so this is the effect that our smoking rate had on our neighbor's y coupled with what our neighbor's y was doing to our y, right? This is that feedback loop, is 1.47. Okay? So this is basically saying in total, right, when we raise the smoking rate, how does that affect us in total? How does that affect both us, but also our neighbor's y, which in turn affects us? Okay? So hopefully that makes sense. Hopefully the difference between the lag y having this R parameter and the lag x without the R parameter, hopefully that makes sense. Okay, and as always, please reach out. Thank you.